Ever wonder how Amazon keeps its online empire running so smoothly?
Even when millions of people are shopping at the same time.
Yeah, it's kind of crazy.
It really is.
We're diving into the fascinating world of Dynamo.
The secret sauce behind Amazon's always-on reliability.
We've got the original research paper by the Dynamo team right here.
Ready to break it down.
Get ready for some serious aha moments.
As we uncover how this system makes sure you can always add that last-minute gift to your cart.
Even during the busiest shopping season.
What's fascinating here is that Amazon realized early on
Like really early on.
they needed a system that could handle massive scale and growth.
And remain incredibly dependable.
Yeah, think about it.
You expect things to work seamlessly on Amazon.
Whether you're browsing for deals at lunchtime
Or placing orders in the dead of night.
and the research paper.
Really paints a picture of the sheer scale of Amazon's operation.
We're talking tens of millions of customers.
Tens of thousands of servers.
Those in data centers all over the world.
Even a tiny glitch could have a huge impact, right?
Absolutely.
Like a domino effect.
And that's where Dynamo comes in.
It was purpose-built to address these challenges.
The creators of Dynamo recognized
Pretty early on,
that traditional databases
which are great for many applications.
weren't the best fit for Amazon's unique needs.
Makes sense.
A lot of services
Like shopping carts,
or recommendations
things like that,
primarily require quick data retrieval.
based on a simple key.
It's like looking up a book in a library using its Dewey Decimal Number.
Oh yeah, I get it.
You need that fast, direct access.
So speed and efficiency are key.
For sure.
But how does Dynamo achieve that always-on reliability?
Even when things inevitably go wrong.
Because they do.
That's where things get really interesting.
Oh boy.
Dynamo embraces this concept
This idea.
called eventual consistency.
Okay.
Imagine you're adding items to your cart from your phone and your laptop at the same time.
Oh yeah, that makes sense.
Dynamo doesn't try to force those updates to happen instantly across all its servers.
It doesn't.
Instead, it makes sure those items eventually appear in your cart,
Eventually.
even if there are temporary hiccups along the way.
That's kind of cool, actually.
It's a very elegant solution.
I like it.
It's like promising that your package will arrive,
Okay.
even if the delivery truck hits a bit of traffic.
Yeah.
You'll get it.
That
It just might not be the very second you expect it.
yeah, it's true.
This approach is crucial for maintaining a smooth customer experience,
For sure.
especially when dealing with high traffic volumes.
Lots and lots of traffic.
Rejecting a customer's action
Because a server is temporarily unavailable.
is just not an option in Amazon's world.
You can't just say no.
No, you can't.
Makes sense.
It makes perfect sense.
So eventual consistency is like the guiding principle here.
It's the foundation.
What are the actual mechanisms that make it work?
One of the key techniques is something called consistent hashing.
Consistent hashing.
It ensures that data is distributed evenly across multiple servers.
Okay.
Imagine slicing a pizza
And-
and assigning each slice to a different server.
Ooh, I like where this is going.
Consistent hashing is like making sure each server gets a fair share of those pizza slices.
So it's like a built-in load balancer,
Exactly.
making sure no single server gets overloaded.
That's the idea.
And to make things even more resilient.
Dynamo uses something called virtual nodes.
Virtual net.
Instead of each physical server being represented by just one point on this pizza ring,
Okay.
it can have multiple virtual locations.
So
So if one server goes down,
what happens?
its virtual nodes are redistributed,
Okay.
and the system keeps humming along.
Like nothing happened.
It's designed to be self-healing.
So we've got this system that's designed for speed.
Yep.
And can handle server failures gracefully.
Gracefully is the key word.
But what happens when things get really busy?
And multiple people are trying to update the same data at the same time.
Like what if 2 people try to buy the last remaining item in stock?
That's a great question.
That's going to happen all the time.
It does, and that's where vector clocks come into play.
Vector clocks.
It's a system for tracking the order of updates,
Okay.
even when they happen concurrently.
Concurrently meaning at the same time.
Exactly.
So if I add an item to my cart from my phone,
Okay.
and then someone else removes it from their laptop a few seconds later.
Dynamo keeps track of both actions and the order they happened in.
So it's like a time machine for data,
It's a good way to think about it.
ensuring everything happens in the right order.
That's the goal.
But what if 2 people genuinely try to buy the last item?
At the exact same time.
How does Dynamo handle that kind of conflict?
That's where Dynamo gets even more clever.
Okay, tell me more.
It can actually use 2 different approaches,
Tube.
depending on the specific needs of the application.
That makes sense.
One approach is called syntactic reconciliation.
Syntactic reconciliation.
It involves comparing the different versions of the data
Okay.
and automatically merging them based on predefined rules.
So it's like having a referee
That looks at the different versions of the data
and decides which one wins.
based on a set of rules.
I like it.
And this approach works well for simple data types,
Like numbers or strings.
where it's easy to define clear rules for merging.
Right.
But for more complex data,
Where things get a little fuzzier.
Dynamo offers a more flexible approach
Wait.
called semantic reconciliation.
Semantic reconciliation.
So semantic reconciliation is where the application itself gets to decide how to merge the conflicting versions right.
It's like having a human referee
Who can understand the nuances of the game?
and make judgment calls based on the specific situation.
You got it.
So it's all about finding the right balance
Between automatic conflict resolution.
and the flexibility to handle complex scenarios.
Exactly.
This is all incredibly fascinating.
I'm glad you're enjoying it.
We've gone from understanding how Dynamo ensures data is spread out correctly
To how it survives failures.
to how it deals with multiple updates happening at the same time.
It's a multifaceted system.
But I'm curious, how much control do developers actually have over how Dynamo behaves?
That's a good question.
Can they fine-tune its settings to meet their specific needs?
Absolutely they can.
So what are these magical parameters?
And what kind of control do they offer?
Give me the details.
3 key parameters are,
N and W.
think of them like settings on a camera.
Okay.
You can adjust them to get the perfect shot.
Ah, okay.
N determines how many replicas of each piece of data are stored across different servers.
So it's like having backup copies of your photos.
Just in case something happens to the original.
That makes sense?
More replicas mean greater durability, right?
Exactly.
Then we have R,
Which stands for?
read quorum.
Oh, okay.
This parameter dictates how many replicas need to respond.
For a read operation to be considered successful,
So if R is set to 2,
Dynamo needs to hear back from at least 2 replicas before it returns the data to the application.
precisely,
Okay, and W
the write quorum.
probably works in a similar way, right?
Exactly. W determines how many replicas need to acknowledge a write operation.
Before it's considered successful.
So if W is set to 2,
Then Dynamo needs to confirm the write on at least 2 replicas before it tells the application that the update has been saved.
you got it.
So by tweaking these NR and W parameters
Developers can strike the right balance.
between durability, consistency, and performance,
That's right.
it's like choosing the right settings on your camera.
Depending on the lighting conditions and the type of shot you want to take,
You might sacrifice some image quality for a faster shutter speed.
or vice versa.
It all depends on what's most important for that particular situation.
Exactly.
That's a great analogy.
I try.
So it sounds like Dynamo gives developers a lot of flexibility.
To fine-tune the system to meet their specific needs.
But I'm guessing that Amazon, with its massive scale,
Has done a lot of testing.
to figure out the best settings for their own applications.
Absolutely. They've experimented with various configurations.
To find the sweet spot.
Balancing performance with the need to keep data safe and consistent.
So what have they discovered?
What are some of the common configurations they use?
I'm curious.
One of the most popular configurations is
N equals 3
R equals 2.
and W equals 2.
What does that mean in practical terms?
How did that translate into a user experience?
It means that each piece of data is replicated to 3 different servers.
So even if 1 or 2 servers go down,
The data is still accessible,
okay.
and for read and write operations.
Dynamo needs to get confirmation from at least 2 of those replicas.
This strikes a good balance between data durability and responsiveness.
It's like having a safety net under a trapeze artist.
You've got multiple layers of protection to make sure things go smoothly.
I like that.
It's a vivid image.
It seems like a very sensible approach,
It is.
providing a good level of redundancy without sacrificing speed.
That's the goal.
But I imagine that even with all this cleverness,
There are still challenges when you're operating at Amazon's scale.
how do they deal with things like traffic spikes?
Or temporary server outages.
That's got to be a nightmare.
It can be.
But Dynamo has some ingenious features to handle those situations.
Like hinted handoff and anti-entropy.
Ooh, those sound interesting.
They are.
We'll definitely need to dive into those in the next part of our deep dive.
I'm happy to explain them in more detail.
But before we do, I'd love to get your take on what makes Dynamo so special.
What are some of the key takeaways you think our listeners should remember from this first part of our exploration?
I think the most important takeaway.
Is that Dynamo is a system built for speed, resilience, and flexibility.
It's designed to handle massive scale and constant change.
And it does so with a level of elegance that's truly impressive,
It's like a well-oiled machine,
constantly adapting and adjusting to keep things running smoothly.
even when things get chaotic.
Exactly.
And I think what's really cool,
Is that it's not just about servers and algorithms.
it's about ensuring a seamless experience for the millions of people who use Amazon every day.
That's the ultimate goal.
We've covered a lot of ground in this first part of our deep dive into Dynamo.
We have.
We've explored its core principles, its clever techniques for handling failures and concurrency.
And even some of the ways developers can fine-tune its behavior.
But there's still more to uncover.
There's always more to learn.
In the next part of our journey, we'll delve into those intriguing features you mentioned.
Hinted handoff and anti-entropy.
And we'll see how Dynamo handles those real-world challenges of traffic spikes and server outages.
It's going to be a fascinating discussion.
Stay tuned.
We'll be right back after a short break.
Welcome back to our deep dive into Dynamo.
Glad to be back.
Before we jump into those fascinating features we teased,
Yeah.
let's talk about how Dynamo handles those massive traffic surges.
That can happen especially during peak shopping seasons.
I'm picturing those Black Friday and Cyber Monday sales.
Oh,
That's got to be intense for a system like this.
you're absolutely right. Those peak times can be a real challenge.
So how does Dynamo make sure that no single server gets overwhelmed?
When millions of people are hitting the website at the same time.
It's a good question.
One of the key techniques is using a partition-aware client library.
Partition-aware client library.
Think of it like having a GPS system for your data
Okay.
instead of blindly sending requests to any random server,
The client has a map of the data center.
and knows exactly which server holds the information it needs.
So it's like having a personal shopper who knows the layout of the entire store.
And can take you directly to the item you're looking for.
No more wandering aimlessly through the aisles.
Exactly. This direct routing helps to distribute traffic evenly.
And ensures that requests are handled as quickly as possible.
But Dynamo takes this a step further with something called client-driven coordination.
Client-driven coordination.
That sounds like the client is taking charge.
In a way it is.
Traditionally, you'd have a central server,
Acting as a traffic cop.
directing requests to the appropriate nodes.
But with client-driven coordination.
The client itself takes on some of that responsibility.
It does.
It periodically fetches information about the system's layout.
Like which servers are responsible for which data.
So the client becomes like a savvy traveler who does their research before heading to the airport.
They know which gate to go to.
And don't need to rely on a central information desk.
That's a great analogy.
And this approach has some real advantages.
Like what?
It reduces latency.
Because you're cutting out that extra hop through a central coordinator.
It also improves load balancing because the clients themselves are distributing their requests.
Based on the latest information about the system's state.
So it's a win-win situation, faster responses.
And a more evenly distributed load.
But what about those situations where a server does go down?
How does Dynamo handle that kind of failure?
That's where a hinted handoff comes into play.
Which we mentioned earlier.
It's a clever mechanism for ensuring that data updates don't get lost.
Even if a server is temporarily unavailable.
Think of it like leaving a note for a neighbor to pick up a package if you're not home.
So if a server is down,
The data intended for that server is temporarily stored somewhere else with a hint about its original destination.
exactly, and when the original server comes back online,
That temporarily stored data is delivered to it.
maintaining the desired level of replication,
It's like a backup plan for data delivery.
ensuring that nothing gets lost in transit.
That's the idea.
Hinted handoff sounds like a brilliant solution.
For those temporary hiccups.
But what about those situations where you need to make sure,
That all the replicas of a piece of data are eventually consistent.
even if there have been network glitches or server outages?
How does Dynamo handle that long-term synchronization?
That's a good question.
That's where anti-entropy comes in.
Anti-entropy.
It's a background process that uses something called Merkle trees.
Okay, Merkle trees sound pretty technical.
To efficiently compare the data on different replicas and identify any inconsistencies,
Can you break that down for us?
imagine each replica has a fingerprint that represents its data.
A fingerprint
A Merkle tree is a special kind of data structure.
that allows you to compare these fingerprints very efficiently. If the fingerprints match, the replicas are in sync,
But if they don't match, the Merkle tree can help you quickly pinpoint the exact differences,
so it's like a detective using fingerprints to identify a suspect.
instead of comparing every detail.
They can use the fingerprints to quickly narrow down the possibilities.
That's a great analogy.
And this efficient comparison process is crucial
for ensuring data consistency across the entire system.
without putting a heavy burden on the network or the individual servers.
It's all about efficiency,
All of these mechanisms hinted handoff,
anti-entropy,
load balancing,
and client-driven coordination
they all seem to work together seamlessly.
to create this incredibly robust and resilient system.
It's like a well-choreographed dance where each dancer knows their steps perfectly.
And even if someone stumbles, the show goes on.
And it highlights the fact that even though we're talking about technical concepts,
It's all about creating a smooth and reliable experience for the end user.
whether they're adding items to their cart, browsing for products, or placing an order,
They should never have to worry about the technical details behind the scenes.
it's like magic, but it's really just a lot of clever engineering.
And a deep understanding of the problems they're trying to solve.
But I imagine that even with all these optimizations,
There are still challenges to overcome.
when you're dealing with a system as complex as Dynamo,
Absolutely. One of the challenges they discuss in the research paper.
is the need to balance those background tasks with foreground operations.
Remember how we talked about Dynamo constantly doing things in the background?
Replicating data, synchronizing replicas, handling hinted handoffs, and so on.
It's like trying to keep your house clean while also hosting a party.
You don't want your guests to trip over a vacuum cleaner.
Exactly. If Dynamo's background tasks become too aggressive,
They could start to interfere with those foreground operations.
those read and write requests that are actually serving customers.
So how do they prevent those background tasks from hogging all the resources?
And slowing things down for the users.
That question.
They've implemented something called admission control.
Admission control.
It's essentially a way to throttle those background tasks.
Ensuring they don't get out of hand and impact the performance of those critical foreground operations. So it's like having a bouncer at the door of your data center.
Making sure the party doesn't get too wild.
But how does this admission control mechanism actually work?
They use a feedback mechanism based on the performance of the foreground tasks.
Okay.
The system constantly monitors things like latency for disk operations
Database lock contention.
and request queue wait times.
So if these metrics start to approach predefined thresholds,
It's a sign that the background tasks are causing problems.
it's like having a network of sensors throughout the data center.
Keeping an eye on everything and sounding the alarm if things start to get out of hand.
Exactly. And when the alarm bells start ringing,
The admission control mechanism kicks in.
reducing the number of resources available to those background tasks.
It's a way to dynamically adjust the balance between background and foreground activities,
Ensuring that the system remains responsive to customer requests.
even while it's busy keeping itself healthy behind the scenes.
That's incredibly clever.
It's a self-tuning engine constantly adjusting itself to maintain optimal performance.
I'm truly impressed by the level of thought and engineering that has gone into Dynamo.
It's a remarkable system.
But it's not just a theoretical exercise, right?
They've actually been running this system in production for years at Amazon.
And they've learned a lot along the way.
What are some of the key insights they've gained from that real-world experience?
They highlight several important lessons learned.
For example, they discovered that those divergent versions
Those cases where multiple copies of a piece of data have conflicting updates.
are actually quite rare.
Really?
And when they do occur, they're more often caused by concurrent writes.
Then by system failures.
So it's not so much about servers crashing or networks going down.
But more about lots of people trying to update the same data at the same time.
Exactly. And they've found that this is often due to automated clients
Those bots and crawlers that roam the web.
rather than human users.
It's a reminder that even in a well-designed system, unexpected behavior can emerge.
And it's important to be adaptable.
But despite those challenges, Dynamo has clearly been a huge success for Amazon,
They've achieved impressive levels of availability, performance, and scalability.
all while running on commodity hardware.
It's a real testament to the power of smart engineering.
It's an inspiring example of how to design systems that are both robust and efficient.
Dynamo's principles and techniques have influenced a whole generation of distributed systems.
And its legacy continues to shape the way we think about building reliable applications.
It's like a blueprint for building the digital infrastructure of the future.
But even with all of its success,
The Dynamo team acknowledges that there are limitations to their approach.
they mentioned some challenges with scaling to even larger systems.
What did they learn about that?
They point out that their full membership model
Where every node knows about every other node in the system.
works well for systems with a few hundred nodes.
But as you start to scale to thousands or tens of thousands of nodes,
That approach becomes less practical.
the overhead of maintaining and sharing that full membership information
Starts to become a bottleneck.
So it's like trying to organize a party where everyone has to keep track of everyone else's contact information.
It works fine with a small group, but it becomes a logistical nightmare as the guest list grows.
Exactly. They suggest that hierarchical extensions to Dynamo might be necessary.
To address this scalability challenge,
In other words, you'd need to introduce some kind of structure or hierarchy to the system.
rather than having every node be completely equal.
So instead of one giant party, you break it down into smaller, more manageable groups.
Each with their own point of contact,
Precisely this idea of introducing hierarchy to improve scalability.
is a common theme in distributed system design.
It's one of the ways we can build systems that can handle the ever-growing demands of our digital world.
What an incredible journey this has been so far.
I'm glad you're enjoying it.
We've explored the depth of Dynamo's architecture, from load balancing to hinted handoff to anti-entropy.
And even peeked into the challenges of scaling such a massive system.
Before we wrap up, what stood out to you as the most surprising or insightful aspect of Dynamo?
For me, it's the emphasis on embracing eventual consistency.
It's a departure from the traditional approach of prioritizing strong consistency.
And it's a key enabler of Dynamo's impressive availability and scalability.
I totally agree. It's a reminder that sometimes you need to challenge those long-held assumptions.
And explore different trade-offs to achieve your goals.
But for me, the real aha moment was understanding how all these seemingly complex mechanisms
Like consistent hashing vector clocks and Merkle trees.
work together so elegantly to create a system that's both incredibly robust and remarkably efficient.
It's a testament to the power of human ingenuity, and a reminder that complex problems often have elegant solutions.
If you're willing to think outside the box,
Exactly.
we've covered a ton of ground in this second part of our deep dive into Dynamo.
We have.
We've explored how it handles massive traffic loads, how it gracefully recovers from failures,
And how it ensures data consistency across the entire system.
but there's one more crucial piece of the puzzle.
How is Dynamo actually used by various services within Amazon?
What real-world problems does it solve?
You're right in the final part of our deep dive.
We'll explore the different ways Dynamo is being utilized in practice.
We'll see how it powers everything from shopping carts to recommendations to order fulfillment.
Stay tuned for the exciting conclusion of our Dynamo adventure. Welcome back to the final part of our deep dive into Dynamo.
We've uncovered its inner workings.
Its clever techniques for handling failures and traffic.
And now it's time to see how it's actually used in practice.
I'm excited to hear about the real-world impact of all this technical wizardry,
Dynamo powers a wide range of services at Amazon.
each with its own unique needs and configuration,
The research paper highlights a few common patterns.
that show just how flexible Dynamo can be.
One common approach is business logic-specific reconciliation.
Business logic-specific reconciliation.
Remember how we discussed how Dynamo can handle conflicting updates to the same data?
Yeah,
This pattern puts the power of resolving those conflicts in the hands of the application developers themselves.
so it's like giving the developers the tool.
To create custom rules for how to merge those different versions of the data.
Exactly.
It acknowledges that there's no one-size-fits-all solution for conflict resolution.
Right.
Sometimes the best way to handle it,
Is to let the application itself decide what makes sense.
based on its specific logic and the context of the situation,
So it's about giving developers the flexibility.
to create the best possible experience for their users.
Makes sense.
Another common pattern is timestamp-based reconciliation,
Timestamp-based reconciliation,
which is a simpler approach.
where Dynamo itself handles the conflict resolution
It uses the timestamps of the different versions
to determine the most recent one.
and discards the older versions.
So it's like a last right wins
Yeah.
strategy.
Whichever version has the most recent timestamp is considered the winner.
That's right.
It's a good fit for applications where the data is relatively straightforward.
And the order of updates is important.
But you don't need complex merging logic.
Right.
It's a streamlined way to ensure you're always working with the latest information.
Okay, cool.
And this highlights another key takeaway about Dynamo.
It's adaptability.
It can be tailored to fit a wide range of needs.
From complex conflict resolution scenarios.
To simple timestamp-based updates.
But there's one more usage pattern that really showcases Dynamo's power and efficiency.
Oh.
I'm all ears.
This pattern involves using Dynamo as a high-performance read engine.
High-performance read engine,
Think of those services that have a ton of read requests.
but relatively few updates.
Dynamo can act as a super fast cache for the data, while a more traditional database handles the actual storage and updating behind the scenes,
So it's like having a dedicated team of speed readers.
who can quickly fetch information from Dynamo.
while a separate team manages the library's collection in the background.
That's a great way to visualize it.
This approach can dramatically improve performance for those read-heavy applications.
Ensuring that users get the information they need as quickly as possible,
It's all about optimizing the user experience.
even when dealing with massive amounts of data.
Exactly.
And it underscores a crucial aspect of distributed systems design.
Understanding the trade-offs.
We've discussed the balance between consistency and availability,
But there are other trade-offs to consider,
like speed versus storage capacity.
or simplicity versus flexibility.
It's like choosing the right tool for the job.
You wouldn't use a hammer to screw in a light bulb.
That's right.
And Dynamo's designers have created a system,
That offers a wide range of tools and settings.
allowing developers to choose the best approach for their particular needs.
This deep dive into Dynamo has been an incredible journey,
We've gone from understanding its core concepts,
to exploring its real-world applications.
and it's clear that this system has revolutionized the way we build reliable and scalable applications.
I completely agree.
Dynamo's principles and techniques have had a profound impact,
On the field of distributed systems,
and its legacy continues to inspire innovation,
it's like a blueprint for building the future of the internet.
ensuring that our digital experiences are smooth, reliable, and lightning fast.
And one final thought for our listeners to ponder.
As we become increasingly reliant on technology
It's crucial that we develop systems.
that can keep pace with our growing demands.
Dynamo provides valuable lessons about how to build systems that are resilient, adaptable.
And capable of handling the challenges of our ever-evolving digital world.
That's a powerful message.
Dynamo's success is a testament to the power of human ingenuity.
And a reminder that even complex problems can have elegant solutions.
It's been a fascinating journey exploring the depths of this remarkable system.
And we hope you've enjoyed it as much as we have.
It's been a pleasure sharing our insights into the world of Dynamo.
Until next time.
Keep seeking knowledge, keep asking questions, and keep diving deep.
And thank you for joining us on this deep dive into Dynamo.
We'll see you next time on The Deep Dive.